Okay, so in this video, let's have a look at graphs of logarithmic functions, and given a graph with transformations, be able to identify the equation for the graph. So here we have an equation for our function. We're told it's a natural log function with an intercept of 0, natural log of 4, and we want to describe in order a series of transformations that we'll map the graph of y equals the natural log of x onto the graph of y equals g of x in terms of m and c. Well, we need to understand our basic logarithmic function, our basic natural log function, and we know that our basic natural log function has a little something like this. It has a y-intercept at 1, or excuse me, an x-intercept at 1. It has x equals 0 as an asymptote, right? And we happen to know that if x is equal to e, y is equal to 1, right? So the basics for our graph. So here we can see that we've had reflection over the y-axis, right? And then with that information, we'll be able to describe our transformations, right? So for part A, we can say that our transformations are that we had a reflection over the y-axis. All right. Now, technically, because we have that reflection over the y-axis, we know that m is less than 0. Okay. So after our reflection over the y-axis, right, if we're going to talk about that reflection first, we have to understand that we're in this form m parentheses x plus c over m for talking about our transformation. So after reflecting over the y-axis, we can talk about that we compress horizontally by a factor of m, right? And then lastly, we can say that we move to the left, right? We can talk about that we move to the left, and in this case, actually, it won't be to the left because we're going to be factoring out something that we know is negative. So we know it's going to need to move to the right, and we're going to need to move to the right, right? We're going to need to move to the right by c over m, okay? Now, technically, we could discuss the transformation in a slightly different way, and the slightly different way that we could discuss the transformation is as follows, right? We could also say that we move left by c units, right? And after moving left by c units, we compress horizontally by a factor of m, and then at the end, we reflect the y-axis. Me personally, I find it easier to discuss in those terms for this particular problem, that we move to the left by c units because we have the plus c, right? So we can discuss that first. Then we can discuss the compression by a factor of m, and then of course what we can see clearly is that reflection in the y-axis. Okay, then in order to determine the value of c and the value of m, what we can do is come in and say, okay, well, we have a point on the graph, and that is this y-intercept, and that y-intercept is 0, natural log of 4. We also are able to see that we have this vertical asymptote, x equals 2. All right, so for part B, if x is 0, that's g of 0. So g of 0 is going to be the natural log of 0 plus c, right? So therefore, c must be equal to 4 because g of 0 is just the natural log of c, and we know that that y-intercept, we're told, is the natural log of 4. Okay, then in terms of our vertical asymptote, our vertical asymptote is going to be based on mx plus c is equal to 0, right? If that interior of this logarithm is equal to 0, that's our vertical asymptote, right? So therefore, if mx is equal to negative c, or if x is equal to negative c over m, and we know that that's going to be equal to 2. Okay, well, if c over m is equal to 2, then that means that m must be equal to negative 2, because negative 4 divided by negative 2 is equal to 2. So we can say then that g of x must be equal to the natural log of negative 2x plus 4. If we wanted to, we could check our work with a calculator, but for this particular assessment, we have non-calculator work, and so we want to make sure that we understand that approach without a calculator. Okay? Thank you for your time. Please ask questions as you need.